So good afternoon to everybody. Today we are going to say about microprocessor configuration. In this microprocessor configuration, there are three types. One is closely coupled, loosely coupled. The last one is what's the other one? One is closely coupled, then loosely coupled. What's the other one? It's a coprocessor configuration.
Coprocessor.
Yeah, coprocessor. So this coprocessor and closely coupled configuration both are same with small changes is there. I'll tell you the small changes. So this coprocessor and closely coupled diagram are same. This coprocessor is called as 8087 math coprocessor. The function of this coprocessor is to perform mathematical operation, that is math operation. In 8086, it is not possible to perform floating point operation. In order to perform this floating point operation, we are going for this 8087 math coprocessor. Likewise, the closely coupled configuration is called as 8089 and loosely coupled is called as multibus. Let us see the diagram for this. Before going to the diagram, this closely coupled and loosely coupled shares memory, same memory, IO system, bus and control bus and clock signals. This is the diagram for closely coupled configuration. A diagram for closely coupled and coprocessor is same. This is a diagram for closely coupled and coprocessor. Diagram is same. Here 8086 processor there and coprocessor is connected to this. Both 8086 and coprocessor control bus, memory and IO are same. Now let us see the how this process takes place in my microprocessor. In the microprocessor, 8086 microprocessor, we are going to write instructions. That is, in instructions, we are going to write both 8086 instruction and 8087 instructions.
Money.
Please don't distract. Here in 8086 microprocessor, we are going to write two instructions. That is, we are going to write 8086 instruction and 8087 instructions. So microprocessor will execute the instruction. So at the same time, these instructions will be monitored by 8087 processor. So in order to differentiate the 8086 instruction with the 8087 instruction, we are going to use instruction escape. That is, if I'm going to write a 8087 instruction, prior to the instruction, I'm going to insert the instruction escape. If escape is read by this coprocessor, then the control will be transferred to this coprocessor, and the coprocessor will execute the instruction. Whatever instruction next to this escape will be executed by this 8087 coprocessor. Then the 8087 processor will deactivate the test pin which is there in 8086 microprocessor. So after that, after finishing the operation, the 8087 coprocessor will activate this test pin. Once test pin is in high.
எல்லாரும் மியூட் பண்ணிட்டாங்க சார்.
Okay, so in closely coupled configuration, we are going to use instruction called out instruction. So there we are going to use in coprocessor, that is in coprocessor, we are going to use escape instruction. Here we are going to use out instruction. So once out instruction is read by this processor 8089, then control will transfer here to this 8087. Then this 8089 will execute the instruction. At the end of the instruction, it will send the interrupt instruction. So once interrupt is read by microprocessor, then it will take control of the instructions. So this process takes place in coprocessor and closely coupled configuration. The last one is your loosely coupled configuration. In loosely coupled configuration, it is not, we are going to divide into modules, number of modules. Here single module is used. In my coprocessor and closely coupled configuration, a single module is used. Here coprocessor and the microprocessor shares address bus, memory and IO signals. But here in my loosely coupled configuration, we are going to use different modules. Here different modules shares different address lines, data lines and IO, right? So this is a difference. By doing this, if any we can perform multiple operation at a time, and if any module failure, then the other module can work. That is, instead of affecting the other module, the individual module can work independently without affecting the other one. That is a process, and the ultimate aim of this loosely coupled is multiple functions can be performed using this loosely coupled configuration. Okay. Okay. Next one is advanced processor. This in advanced processor, we are going to say about 80186, 80286, 386, 486, and Pentium 4 and co-processor. So this sheets explain about the multi-processor. This single sheet, using the single sheet, you can write a number of points. That is, use 80186. It's having 16 data lines and it's having 20 address lines. And the memory
Hello,
capacity is of சொல்லுங்க
sir.
சொல்லுங்க.
கொஞ்சம்
Okay, fine. Okay. So
ஸ்லோவா சொல்லுங்க சார்.
okay, so this is my advanced processor. In advanced processor, we are going to use 80186, 286, 386, then 486. Last one is Pentium 4 and Core 2. So using this single block, that is single diagram, you can write n number of points. So 80186, for 80186, the address lines is of 16 bits. The data lines is of 16 bits. Address lines is of 20 bits. And the memory capacity of this 80186 is 1 MB. How we are going to calculate this memory capacity? How it is possible to find this memory capacity? Can anyone answer this question? Any idea? By using this address line, that is 2 power 20 will give 1 MB. Right? The same thing happens for my 80286. For 80286, data lines is of 16 bits, address lines is of 24 bits. So the memory capacity is of 16 MB. So if 2 power 24, we are going to substitute 2 power 24, which is equal to 16 MB. So for different processor, different address lines and data lines are given. The memory capacity is based upon the address width. So 2 power 40 is 1 terahertz. 2 power 32 is 4 gigahertz. 2 power 32 is 4 gigahertz again. 2 power 24 is 16 megabits. Sorry, megabits is gigabits. So based upon the address lines, we are going to find the memory capacity. So okay. So if you are very familiar about this address lines, then you can explain about this memory capacity of this advanced processor. Okay. So in unit 2, you should be very familiar about the pin diagram. If you are familiar with pin diagram, there are no issues. You have to write about pin diagram, then you have to write about SFRs, then so not SFR, SFR is native tune. Okay, you have to write about the multiprocessor configuration. Okay, then you have to write about advanced processor. So these are the important question in unit 2. Now coming to unit 3. Unit 3 is, what is the topic? Unit 3. In unit 3, our main topic is parallel communication interface. What is the other name for parallel communication interface? Can anyone tell me the answer for this? What is the other name for parallel communication interface? Or else just give me an example for parallel communication interface. Any example for parallel communication interface?
Printer, sir.
Printer to microprocessor. Very good answer. Printer to microprocessor is a very good example for parallel communication interface. So parallel communication interface is called as PPI or A255. Okay, and this is the pin diagram of A255. Here in A255, you should know about the block diagram, and before going to the block diagram, you should know about this pin diagram. So in pin diagram, it's a 40 pin IC. This 40 pin IC consists of D0 to D7, that is data lines. 7 data lines are there. From D0 to D7, 7 data lines are there. And here we are going to use 3 ports. One is port A, port B, and port C. Each port is having 8 bits. Port A 0 to port A 7. Likewise, port B 0 to port B 7, and port C 0 to port C 7. So totally 24 pins are used for these ports. Port A, port B, port C uses 24 lines, that is pins in this 8255. And with this, we are going to use data lines D0 to D7. It's of 8 lines. So totally 32 lines out of 40 pins. 32 pins are used for port A, port B, port C, and for data lines. And remaining only 8 pins are there. These 8 pins is meant for read, control, CS bar pin, ground, A1, A0, then WR bar, reset, then VCC last. That's all. You know about this. That is, whatever point you are going to write in 8086, that is pin diagram in 8086, the same points you can write here for WR bar, reset, ground, CS bar, RD bar. Okay, the same points you can write here, right? And now we are going to see about the function of each ports, that is port A, port B, port C, and the data lines. You are very familiar about the data lines, D0 to D7. You are all very familiar about it. Okay, so once draw this diagram, explain about the pin diagram and explain about the ports. Okay, so this is a simple diagram of pin diagram of 8255. Okay, and in 8255, so 24 pins are there, that is port A, port B, port C are called as 24 input output lines. And these ports are grouped into two, as group A and group B. So in group A, port A and port C upper is there, and in group B, port B and port C lower is there, right? So port A consists of port A0 to port A7, PA0 to PA7. Port B consists of PB0 to PB7, and port C is divided as is consists of PC7 to PC0, right? And this port C is divided as port C upper and port C lower. In port C upper, it consists of PC4 to PC7, and port C lower consists of PC0 to PC3. Okay, you all very familiar about it. Our ultimate aim in 8255 is to draw this diagram. If you draw this diagram, then you can write the answers very easily. Okay, so data lines, why this data bus buffer? Data lines will be transmitted, right? And this block diagram represent this pin diagram. See this pin diagram. You have to just draw this pin diagram in this form of this block diagram. That's all. Okay, in the form of this block diagram. So this is my data bus buffer. Via this data bus buffer, D0 to D7 lines will be entered via this data bus buffer. And this read write control logic, via this read write control logic, read write A1, it is A0 A1, reset, and the CS chip select line. So chip select line is very, very important. This chip select line is always 0. If this chip select line is 1, then nothing will be transmitted from microprocessor to the to other devices, that is to peripheral devices. In order to transmit data from microprocessor to this IO device, I have to make this CS bar pin to 0. If it is 1, then no data will be transmitted. So this CS bar act as a key. So we have to make this line CS bar as 0 always. So take care about this CS bar. Then reset. If it is 1, it will reset this 8255. So via this read write control logic, we are going to give an RD bar, that is I can write the data and I can read the data via this port, and A0 and A1 for address lines. So I'm going to use this read write logic here, that is read write logic block here, and data bus buffer block here, and group A and group B. You all know about this. Yeah, actually we have divided here group A and group B. So group A consists of port A and port C upper. Likewise, group B consists of port B and port C lower. So the same thing happens here. So group A consists of port A and port C upper. Group B consists of that is port B up, port B, it's upper or lower? Fully, that is port B is fully, it's having 8 bits. So port B and port C is lower bits, that is PC0 to PC3 is used here. So the diagram is very important. If you draw the diagram and sure about it, you can definitely explain the concepts. That nothing is there, right? So diagram is very important as far as this 8255 is concerned. So this 8255 consists of two modes. So mode 1, that is, what are the two modes available? The two modes are IO mode and BSR mode. This is my BSR mode. There is IO mode, input output mode, and this is the control word format of my 8255. right? So based upon the values here in this control load format, I can select the particular ports or particular modes can be selected, right? Likewise in BSR mode, only one bit. I'm going to select my port. That is, I have to select my port C. So in port C, so here B3, B2, B1. Who's B3 here? B3, B2, yeah, B3, B2, and B1. This one, B3, B2, B1, and B0. Here, if I'm going to give here value, that is 0, 0, 0. If the three values are 0, 0, 0, 0, that is B2 0, B1 0, B0 is a 0, then port C 0 will selected. Likewise, 0, 0, 1, port C 1 will selected. If the value is 1, 0, 1, then port C 5 will be selected. So port C selection is done by using this BSR mode. BSR means bit set reset mode. Here this D7th bit is always what? It's always 0, right? If it is 1, whatever value we are going to give here, it will not consider this value, it will not consider that port. So based upon the values here at the D7th bit, the particular port will be selected based upon this value in D7th bit. If D7th bit is 1, so nothing will happen here. So take care about it. D7th bit should always 0 in BSR mode. Okay. Likewise, in my IO mode, this D7th bit is always 1, right? If it is 0, so whatever value we are going to give here, it will not consider that value. So take care about this D7th bit. D7th bit is always 1 in my IO mode. Okay. So in 8255, you have to know about this pin diagram, block diagram. Then two modes are there, BSR mode and IO mode. Likewise, this CS bar, that is, we are going to select the address, that is A1 and A0. Using this A1 and A0, with this chip select bit, we are going to select the particular ports. See here, for all the values, my CS pin is 0, except for the last one. If my CS pin is 1, whatever value we are going to give here in A1 and A0, it's not going to select the particular port or particular whatever it is, controller format. It will not select anything if the CS bar is pin is 1. So take care that CS bar pin is always 0. Okay. Now based upon the values in my CS bar, I'm going to give different values to this A1 and A0. If A1 and A0 is 0, 0, port A will selected. If A1 and A0 is 0, 1, then port B is selected. If A1 and A0 is 1, 0, then port C is selected. If both are 1, then control register is selected. In all the cases, CS bar is 0. Right? If CS bar is 1, nothing will happen. So take care of about this CS bar pin. So CS bar pin is always 0 here in 8255. So in 8255, you have to draw about the pin diagram. You have to draw about, you have to write, you have to explain about all the extra pins. That is D0 to D7, CS bar, reset, WR bar, RD bar, and A1 to A0. Then you have to write about ports. That is port A, port B, port C, right? Then how we are going to divide this, grouping this group A and group B. Then block diagram. After block diagram, you have to explain about the uh, control load formats. That is, two control load formats are available. One is IO mode, the other one is BSR mode, right? So if you are familiar with this diagram, block diagram, uh, and you can draw all the diagrams which is there in unit 3. Okay. So data bus buffer and rated logic, please draw this diagram 2 to 3 times. So if you draw the diagram clearly for 2 to 3 times, then you can draw all the diagrams. Let us see the diagrams one by one in the next coming classes. Okay. Here